Good morning, my dear students. Today we are going to see the continuation of chapter number 3, computer organization. So today, what is the topic we are going to discuss? Data communication between CPU and memory. This is the topic. So this topic, especially what we are going to discuss, means how the data communication process should be happen between the CPU and memory. Okay. Already we know well, CPU is the important part or unit. It will be performing all the actions inside the computer, right? So this topic, how should be the data communication process should be happen between the CPU and memory, okay? Or how it is the data communication process will be happen, okay? So first of all, the CPU have a two different parts. Number one, memory data register, that is MDR. Number two, memory address register, that is MAR. So what is the difference between these two? And what it will do inside the CPU? Okay, we'll see one by one. The first thing is the memory data register keeps the data which is transferred between the memory and the CPU. So what is the purpose? It is the location. It should be transfer the data between the memory device and the CPU. Okay. So what data you want to transfer from the memory to CPU, that all the data should be included in the part. That is what MDR, memory data register. So whatever the data should be transferred from the memory to CPU, all should be stored here. Okay. The next one, what is program counter? It is another special register is available in CPU, which is always keeps the address of the next instructions to be executed. Okay. So whatever the instructions will do or execute one by one, everything should be ordered in the special register. That's the name is what? Program counter. So you are simply called PC. Okay. So that is the main purpose of this program counter. Understood? The next, it will perform arithmetic and logical unit of CPU. It places the address of the memory to be fetched into the memory address register. So the memory address register is another part. It will do all the arithmetic and logical unit of CPU. It have the memories to be fetched. What it will be performing or what execution will be performing. Okay, so everything will be stored in the memory address register. And the next thing is, what is bus? Bus is nothing but what? Generally, bus is one of the medium. It is a collection of wires used for what purpose? Communication purpose between the devices inside the computer or CPU. It is already presented in the internal components of your computer. So where the bus should be located, it is also one of the internal components of your computer or CPU. It is a medium to communicate between the devices inside the CPU. That is the main purpose of what? This bus. Okay. So as per the textbook, page number 34, a bus is a collection of wires used for communication between the internal components of your computer. That is a understandable definition of bus. Okay, right. So these are the important actions we'll do as per the instructions. The word and the RAM has the same size. So already we know what is the meaning of RAM, random access memory. It has memory data register. Okay, why means it will know about how the data should be processed, how much information should be executed as per the instructions. So that is the main important thing. If the processor is an 8-bit processor like Intel 8085, its MDR and the word and the RAM both have 8 bits. So both the RAM and also MDR is very important to perform any type of data execution in the CPU. Okay, so memory data register and also RAM both are having a same size. Then only the data should be executed or processed in a equal speed. That is very important. Okay, so these are the methods we can follow to perform an action. Okay, yes. And then the read operations. So generally we have two different types of operation. One is read operation, another one is write operation. So read operation transfers the data from word to memory data register. The write operation transfers the data from memory data register to word. These are the difference between the two operations. Okay. So the first one is what? The read operation. The data should be read in the CPU. What it will be happen? That means it transfers the data, that is the number of bits of data from word to memory data register. That is the action of read operation. The next one, write operation, is nothing but it transfers the data from memory data register to word. These are the two by communication process inside the CPU. Okay, so these are the ways the communication process should be happen between the CPU and memory. Okay, so all the students, please understand, once you use the CPU or once the data should be processed inside the CPU, these are the mechanisms should follow. Okay, we'll see one by one in the microprocessor. So everything will be based on your processor. Your data execution will be speed will be automatically increased. Okay, right. The next topic, 3.4, types of microprocessor. So we have two different types of microprocessor as per the classification. One is the width of the data that can be processed. The number two, as per the instruction set. These are the two ways we are mainly classified into the different parts or types of microprocessor. We'll see one by one. The first thing is classification of microprocessor based on data width. So in this topic, especially what it will be specifically deals with, the depending on the data width, microprocessor can process the instruction. So what is the meaning of data width? Data width is nothing but how much data should be performing or executing in a single second. Yes, so that is nothing but what? Data width. So this data width based on the microprocessor as per the instructions, there are four different types. Number one, 8-bit microprocessor. Number two, 16-bit microprocessor. Number three, 32-bit. And number four is 64-bit microprocessor. These are the four different types of microprocessor we have based on the classification of data width. Okay? Yes. The classification of microprocessor based on instruction set, what it will be involves. Okay? As per the instruction set, how it should be classified in the microprocessor. The first thing is the size of the instruction set is another important consideration while categorizing the microprocessor. Yeah, of course. What is the size of the instruction set? How much data you want to execute? That data size should be very important to measure and it will be performing the action. Yeah, normally if you are doing a very big process means it will be take some time to do the particular process. Is it correct? But if you are doing a small kind of work in the computer means it will do immediately. Yes. So how it should be processed? Everything should be based on the size of the instructions, what you are given or what work we are going to give. Everything will be based on the size. That is what size is nothing but what? Memory size. So initially microprocessors had a very small instruction set because the complex hardware was expensive as well as difficult to build. Yeah, of course. So complex hardware components, if you want to use inside the computer, it will take more microprocessor action. That means it will occupy more RAM for executing the particular hardware machines or device, whatever it is. So these are the main important informations about that, this types of microprocessor. Is it okay? Yes. So as the technology had developed to overcome the issues, more and more complex instructions were added, increasing the functionality of microprocessor. Yeah. Why? Because at the earliest period we are executing a very less amount of data. Then after that, so many technologies have come and rule and survive the our society. More and more complex instructions we are going to perform. So that time we need a much more increasing the functionality of microprocessors. So let us learn more about two types of microprocessor based on their instruction set. We'll see one by one. Okay. So the first thing is RISC. What does it mean? It is nothing but reduced instruction set computers. That means what? Reduced instruction set computers means what? It have a small set of highly optimized instructions. Okay, so complex instructions are also implemented using simple instruction. It will reducing the size of the instruction set. So what it happens, it will be reducing the size of the instruction set. Why? Because the size will be increased means automatically the processor will be take more time to execute. Okay, so that's why. So the examples of RISC processors are Pentium 4, Intel P6, AMD K6 and K7. These are the examples of RISC, that is RISC based microprocessor. Okay, the next category, complex instruction set computers. This is the very important instruction set involving in the microprocessor. So the word have a meaning. It supports hundreds of instructions at a time. When compared to RISC, it will be support hundreds of instructions to be executed at a time. So computers supporting CISC can accomplish a wide variety of tasks, making them ideal for the personal computers. So wide variety of tasks. That means what? Multiple variety of tasks we can perform simultaneously and make them our computer should be ideal. Okay. So what are the examples of a CISC processor? That is Intel 386, 486, and Pentium 2 and 3, then Motorola 68000. So these are the examples of CISC processor. Did you understand, my dear students? So based on the classification of microprocessor, we are dividing by two methods. One is width of the data that can be processed. The next one, number of instructions set should be performing inside the microprocessor. Okay, so as per the two important classification, your microprocessor should be categorized. Does it understand, my dear students? Yes. The next topic, another important topic from this lesson, memory devices. So what does it mean? A memory is just like a human brain. It's just like a human brain. It is used to store data and instructions. So what is the purpose of memory generally? It is used for storing the data and instructions. In computer, the memory is the storage space. It should be occupied more memory space. This is the location or storage space to store the data and instructions. Yeah, of course, these things already we know well. So there are two types of accessing methods to access the memory. In the memory device or memory part or location, there are two types of way of accessing methods. One is read method, another one is write method. Okay, and they are sequential and also the random access. What is the difference between these two? Sequential access means one by one, continuously you can access. Random access means by randomly it will be accessing the informations in the particular memory part. Okay, so these are the various information. The next, in sequential access, already I told, memory is accessed in an orderly manner from starting to end. And in the random access, any byte of memory can be accessed directly without navigating through the previous bytes. Okay. Yes, so everything will be based on our request. Okay. Different memory devices are arranged according to the capacity and speed and also cost. We are showing one figure or picture. You just see that these are the different types of memory devices based on the capacity of memory space and speed, how much data should be transferred, and cost wise. We'll see that. So see, a larger capacity and smaller capacity. We are dividing by two method. The first one is cache memory, the next one is main memory, and third one is what? Hard disk. First of all, smaller capacity and faster access time and higher cost means right from hard disk, the next one memory and cache memory. Okay. The next one, larger capacity and slower access time and lower cost means you can follow from a cache memory, main memory and hard disk. That means why this triangle represents the cache memory, main memory, hard disk, it should be low or larger capacity, automatically the slower access time and lower cost. Yeah, of course. Within a short memory part, you can access n number of data and automatically what happen? the requirements are very much lower than your data means, it should be automatically reduce the time, speed or accessing time, and cost also very low because not at all we are using any type of components, and the capacity is also very larger. So the next one, smaller capacity. Smaller capacity, faster access time and higher cost means within a shortest capacity memory, it will be automatically do the fastest action, and finally it will be cost is very much we can use. These are the memory hierarchy. So these are the very important information about that. So generally in our for suppose we are going to buy any mobiles, okay, now you have to buy a mobile in a very much amount, a very high cost means automatically what happen, it will be a fast performance, okay, and higher access timing, okay, and the capacity is also very high. Yes, here they are mentioning smaller capacity means at the very smallest capacity we have to do the process. No, don't take much more space for doing the action. That is the meaning of that. Suppose we are buying this one mobile, that mobile have a lower cost. That time what happened? It will be have larger capacity. So automatically slower access time and lower cost. So these are the memory hierarchy or memory structures about that. Okay, understood? Yes. So first one, random access memory. What is the meaning of that? The main memory is otherwise called random access memory. So what is another name of random access memory? That is what? Primary memory or main memory. This is available in computers in the form of integrated circuits. So where it will be available? In the ICs. It is the place in a computer where the operating system or application programs and the data in current use are kept in temporarily so that they can be accessed by the computer's processor. So it is a temporary memory, you know that, and this location especially what action or what executions we are going to perform in the computer, that everything will be stored in the particular memory part and it will be executed. So all the storage part, everything will be a temporary one. Understood? Right? That is the meaning of this RAM. That is the smallest unit of information that can be stored in the memory is called bit. So already we know bit is the very smallest unit we are storing any data in the computer. The memory can be accessed by a collection of 8 bits, which is called a byte. Yeah, of course, 8 bits equal to 1 byte. The bytes are referred by B, alphabet B. So if your computer has 1 megabyte of memory means it can store how much data of bytes? 10,48,576 bytes or characters are stored in the particular byte. So 1 megabyte data means how much bytes? 10,48,576 bytes of information we can store. Okay, so these are the way the data should be stored and performed in the random access memory. Understood? So and also RAM is one of the volatile memory, which means that information is stored in it's not a permanent. It is not a permanent. So it is a temporary. So all the temporary memory storage space, everything should be called as volatile. That is the meaning of that. Please note down. RAM is a volatile memory. As soon as in RAM, suppose the power is turned off, whatever the data that resides in RAM is lost. Yeah, of course. If you are doing any installation process or any execution process in the computer, that time your computer will be switched off means all the data is stored in the RAM, everything will be lost because the entire action should be switched off, right? So that's why RAM is not performing any action. So all the temporary information, everything will be lost. And it allows both read and write operations. That is what RAM. Okay, so these are the important informations about that RAM. And next topic, what are the types of RAM? Before we are going to see the types of RAM, this is the structural representation of RAM. RAM is looks like that. This RAM will be inserted in the CPU, inside the CPU. This is the position, this is the top position, this is the bottom position. You just insert in the RAM slot. Already in CPU, in motherboard having slot, using the slot you can insert at the random access memory. Okay, yes, fine. So what are the types of RAM? There are two different types of RAM. One is dynamic RAM, another one is static RAM. In dynamic RAM we call as DRAM, and static RAM we call as SRAM. These two types of RAM based on the technologies to hold the data. So dynamic RAM means it being a common type, it needs to be refreshed frequently. Whether it is a static RAM needs to be refreshed less, which make it faster. Hence, static RAM is more expensive than dynamic RAM. What is the difference between these two means? Static RAM means the data should be performed or doing any actions in a constant manner. In dynamic means it should be the data should be performing in a not constant manner. Dynamically it will be changed. So that's why static RAM is more expensive than dynamic RAM. Is it okay? Yes. So the next topic, read-only memory. Okay. So read-only memory is nothing but what? ROM. What does it mean? Okay. So read-only memory refers to a special memory in a computer with the pre-recorded data at manufacturing time, which cannot be modified. I mean that means what? It is a permanent storage part. We can't able to modify it. The stored programs that start the computer and it will be performing some diagnostics are available in ROMs. ROM stores critical programs such as program that boots the computer. Once the data has been written onto the ROM chip, it cannot be modified or removed and can only be read. That means what? Once you store any data in the ROM, it is permanently it will be stored. Okay, so you can't able to remove it. It will be automatically reading. So ROM retains its contents even when the computer is turned off. In RAM, what we have discussed already, during the RAM execution time, your computer will be switched off means all the data should be lost in RAM concept. Is it correct? ROM means it contains even when computer is turned off. Should be retained. The content should be retained means what? The data does not loss. So ROM is called what type of memory? Non-volatile memory. Understood? That is the difference between both RAM and ROM. Okay. These are the structural representation of what? ROM, read-only memory. Okay. Yes. The next one, programmable read-only memory. It is also a non-volatile memory and which data can be written only once. Once a program has been written into a PROM, it remains there forever. That means what? Once you return any data inside the PROM, that is programmable read-only memory, it remains there forever. It is always there. Unlike the main memory, PROMs retain their contents even when the computer is turned off. Yeah, of course. Like ROM, it also retains the contents. Okay. The PROM differs from ROM. And compared to ROM, PROM is differ. Okay. Yes. It is manufactured as a blank memory, whereas ROM is programmed during the manufacturing process itself. That means what? PROM is manufactured as blank memory, but ROM is a programmed during the manufacturing process itself. During the manufacturing process, inside the ROM having some programmed things are there. PROM programmer or PROM burner is used to write data to PROM chip. Underline, that is the very important information. So how to write the data in PROM chip means using the PROM burner or programmer. The process of programming a PROM is called burning the PROM, that is programmable read-only memory. That's all about this PROM. This is a diagrammatic representation of PROM. Okay, right. The next one, erasable programmable read-only memory. That is what? EPROM. So erasable programmable read-only memory is a special type of memory which serves as a PROM, but the content can be erased using ultraviolet rays. So in PROM, we can't able to erase, but in EPROM, we can erase the data using what? UV rays, that is ultraviolet rays. It retains its content until it is exposed to ultraviolet light. So using the ultraviolet light, you can delete the or erase the data. Until that, you can retains the data. Ultraviolet light clears its contents, making it possible to reprogram the memory. So what is the purpose or why they are using ultraviolet rays to erase the information in EPROM? It clears its contents, making it possible to reprogram the memory. That is the main purpose of using ultraviolet rays for erasing the data in EPROM. An EPROM differs from PROM because PROM can be written only once and cannot be erased. Programmable read-only memory we can't able to erase anything. Once you written anything, it is a permanent one. But EPROM, you can erase multiple times. Okay? Yes. These EPROMs are widely used in personal computers because they enable the manufacturer to change the contents of PROM to replace with updated version. Yeah, of course, because in our computer we can update so many things. So we can update so many things means what happened? What you are already stored or written in the data, everything will be replaced. So that's why in our personal computer we can use EPROM widely. Understood? Yes. The last ROM type is EEPROM, electrically erasable programmable read-only memory. That is the last type of last type of ROM. It is a special type of PROM that can be erased by exposing it an electrical charge. In EPROM, how to erase the content using ultraviolet rays. But in EEPROM, we can erase the data by using electrical charge. Like other types of PROM, EEPROM retains its contents even when the power is turned off. When the power is turned off, we can easily retain. Comparing with all other types of ROM, EEPROMs are slower in performance. Very slower performance for executing the data. Okay, that's all about what this EEPROM. That is a pictorial representation of electrically erasable, programmable, read-only memory. Students, please note of it. All the expansion and abbreviation is very important. For each and every abbreviation, you can follow the correct expansion because they are asking one words from this part of way. Okay, so all the expansion and abbreviation should memorize into your memory. It's very important. Okay, the next concept, secondary storage device. Before we are going to discuss about this secondary storage device, what is cache memory? What about the information about that? So cache memory is a very high speed and expensive memory. It's very important, which is used to speed up the memory retrieval process. So what is the purpose of this cache memory? Using this cache memory, you have to increase the speed about the process and the memory retrieval process. Due to its higher cost, the CPU comes with a smaller size of cache memory. Why? Because it is a very high speed of memory part and the process also is very high and expensive. That's why it is very much expensive. So due to the higher cost, all the CPU comes with a smaller size of cache memory compared with the size of the main memory. So without cache memory, every time the CPU requests the data, it has to be fetched from the main memory, which will consume more time. So without cache memory, what is the problem to be raised? What is the problem? For every time CPU requests the data to fetch from the main memory, which will consume more time. So without cache memory means our CPU, every time what data you want to perform, everything will be taken from main memory. So without cache memory, it is not possible to take in a very fast manner. So that's why it will consume more time. So that is a very much drawback of without cache memory, we are performing any data inside the CPU. So that's why cache memory is very important need of this memory execution or data execution. Okay, so that is a very important information about what cache memory. So without cache memory means all the systems should be very slower. Okay, yes. The idea of introducing a cache is that this is extremely fast memory would store the data is frequently accessed and if possible the data that is closer to it, and it helps to achieve the fast response time. Fast response time means what? If you are given any instruction means immediately your processor should be response to you. That is what fast response time. How it will be satisfied with the help of cache memory. Okay, so response time is nothing but access time. How much time to take and execute the instructions. That is the meaning of what? Access time. It will be performing both read and write operations, and if you are giving any request like read and write, everything will be, it will be do a very faster manner. The arrangement of cache memory between the CPU and the main memory is, this is the diagrammatic representation. So this is CPU, this is main memory. In between gap, the cache memory will performing the action. So fetch from the data from CPU and it will be stored. So first of all, in the memory part, the data will be fetching and sending through the CPU, and finally it will be processed and sending back to cache memory, and it will be stored in the main memory. So this is connections between both the CPU and main memory. Okay, so without cache means all the action should be performing in a very much slower operations. Okay, the time will be totally reduced. Okay, that is a very important meaning of this cache memory. Okay, yes. So this is the diagrammatic representation of cache memory. So all the motherboard of CPU, this is the inbuilt cache memory device. The cost is very much high. So that's why if you want to buy externally means it will take more amount. So that's why for all the computers CPU, it is an inbuilt cache memory device is located in the motherboard. It is very much helpful to performing the data between the CPU and memory in a very faster manner. That is the purpose of what? This cache memory. So that's all about the memory devices in CPU. All of you understand, my dear students? If you have any doubt, please refer the textbook. After reading the textbook, if you have any doubt means, you can ask to the particular teachers. Is it okay for you? Yes. The next concept, secondary storage device, we'll see in the next class. Okay. Thank you, all of you.